we go to the second part of the first question. So the second part is a question on probability, and it reads: a box contains 3 black and 2 white marbles of the same size. A marble is taken out at random from the box and not replaced. A second marble is then drawn. Calculate the probability that both marbles are A, white, B, are of different colors. So if you look at this question, they have not specified whether to use a tree diagram or not, but a tree diagram always makes things simpler for you to calculate. So therefore, I will start first of all by drawing a tree diagram to simplify the given information that is there. Okay, so for the first, this marble was drawn twice. The first, it was not replaced, and then it was drawn again. So for the first drawn marble, we are going to have a tree diagram which looks like that. We have a black marbles and we have the white marbles down there. Now, the total marbles that we have there are 5. So the denominator for all these would be what? Would be 5. Now, since the first marble was drawn and not replaced, it means if we look at the black marbles, we are drawing, the probability of drawing a black marble, we are drawing from how many? 3. So it will be 3 out of 5. Again, the probability of drawing a white marble will be what? 2 out of 5. That is the first drawing. Then for the second one, when the second marble was drawn, from this we are going to have something that look like that, where we have also a black and the white down there. Again, we'll have a black and the white down there. One thing you should understand when you're looking at the probability, for the first drawn, we are simply looking at the exact numbers that we've been given there. The first drawing, we are drawing from, the probability of drawing a black marble is 3. Okay, from the 3 marbles that we've been given, and 2 from the white marbles that we've been given. When you look at the second one, for this part, your concentration will be only on the black marble. Okay, so since the first marble was drawn and not replaced, it means it is out from the box. Therefore, the denominator in this case will have to reduce by 1, which will be 4 for both. It will be 4. Therefore, since my concentration will be a black marble, why? If suppose the first marble which was drawn was black, and the second marble again is drawn, it means that for the second marble, since there were 3, now I'm remaining with 2. So the probability of drawing a second one, which is a black, will be drawn out of how many marbles? 2 of them. Okay. Therefore, it means that for the white ones, it has no effect because my concentration is on the black marble. So the white will still have the same numerator, which is 2. The 2 white marbles that we were given. Okay. So when we come down there now, my concentration on this part will be the white marbles. Suppose the first marble which was drawn was white. Therefore, it means that even here, the marbles, the total marbles in the box will have to reduce by 4. The denominator will have to reduce by 4. Then the black marble in this case will have no effect, so it will have to go back to the original 3 black marbles. But for the white, since my concentration now is on the white marble, suppose the second marble which was drawn is white. It means that from the 2 that we had, we only had 1 remaining. So my probability of picking a white marble will be what? Will be 1. So I have something that looks like that. So this will help me now to answer my first question, which is saying calculate the probability that both marbles are white. So you go where you have the white. In most cases, you'll be asked to also show the outcome. So the outcome for this one will be black, which is the probability of black, which is giving us 3 over 5 multiplied by 2 over 4. Where am I getting these numbers? These numbers are getting them from the 3 over 5 for the black and the 2 over 5 for the black. And we have the black white, probability of getting black white, which is 3 over 5. These are the outcomes for the tree diagram that I've written here. I've drawn there. So, what is the probability that both marbles are white? So, we'll look at the probability that where the white are appearing twice. So, the probability of white is this one. So, this is the one that we will get. So, the probability that both are white will be equals to 2 over 5 multiplied by 1 over 4. Okay. When you multiply the numerators, you get 2 over the denominators, we get 20. You can simplify that further, which will give you 2 into 2 is 1, and 2 into 20, that gives you 10, sorry. That gives you 10. Therefore, the probability that both are white is 1 over 10. Okay. Now, the probability that both marbles are of different colors. If you look at the first outcome, it's black, black, and the last outcome is white, white. So the two that are showing that of different colors are the probability that it's blue, white, and the probability that it's black, white, sorry, and the probability that it's white, black. So pick those probabilities. So the probabilities that are of different colors, therefore we are getting the probability that it is black, white, plus the probability that it is white, black. If you add these two probabilities, it will give you the probability of different colors. Therefore, what do we have on black, white? We have 3 over 5 multiplied by 2 over 4, like that, plus this probability. We have 2 over 5 multiplied by 3 over 4. Therefore, this gives us 6 over 20 plus also 6 over 20. Both of them are falling under the same denominator, so we pick one. Then 6 plus 6 will give us 12. If you reduce that further, you can divide a 2 in there. It gives you 2 into 12, it gives you what? 6. Then 2 into 20, it gives you 10. I think you can still simplify this further and find the simplest way in which you can do that. So if you didn't want to divide a 2, you can still divide a 4 into 12, which gives you 3, and a 4 into 20 gives you 5. So therefore, equally here, a 2 into 6 gives you 3, and a 2 into 10 gives you 5. So that's our answer.